today, what I got on here is a 4.6 variation of parameters, and the things that you want to, this is another way of getting y of p. Let me just move this down a bit, this example that we're going to do. Okay, so we're using this, right, and we want to come up with values for u, and then we could use our y of p to be u1 y1 plus u2 y2, sorry, u2 y2. Okay. So this works for our particular solution. Now everything that is here everything in that box you want to know, okay, you want to have available so that you can do these pretty easily. Okay, so I'm going to go through this, and again, we're going back to that matrix with the determinant with the Wronstein value, okay, for functions. So we're using that same idea here. We have a 2 by 2. Okay, so what I want to show you is this first example, and again, we want to find y of c first, right? Because it's going to help us with our y1 and y2. So you go back to that 4.3, we get m squared minus 4m plus 4 equal to 0. So you do this as a homogeneous, right? So here you get m minus 2, m minus 2. Here we have a repeat. So we know y1 is going to equal, well, let me write what m equals first. So m is going to be 2, so we know that if we're looking for our y of c, we would have c1 e to the 2x plus c2 x e to the 2x. Remember, because it repeats, and then you know y1 is e to the 2x, and y2 is going to be x e to the 2x. All right, and that's important. So that's your first step here, and basically it's, you know, another method that you could use, because if you look at what the function is equal to on the right side, it's pretty tough to do with our last method when we did what you want to call it, the superposition approach, which you may not want to do with this method, and I don't mind. However you get the answers is fine. Even if you're in 4.4 and you want to use this method, this is all right, even though this is 4.6. Okay, so the next thing I'm going to do is set up all these matrices, right? So W here, right, so if you go back, W up here, okay, if you notice, it's y1 and then y prime of 1 is below that, and y2 and y prime of 2 below that. So what I'll have here, whoops, is y1, right, and what's the derivative? Okay, 2e to the 2x, and then y2, and then this derivative is product rule, so you have derivative of x is 1, so e to the 2x plus 2x e to the 2x. So you have this set up. So now this is equal to, right, so remember you multiply across, so we get e to the 4x plus 2x e to the 4x, and then minus, and then you go across, right, and you get 2x e to the 4x. So we just get for w e to the 4x. All right, for w of 1, right, w sub 1, okay, now we're going back up to this. Okay, if you notice here, it's 0 and then f of x. This function that it's equal to is considered f of x. So we would have 0, x plus 1, e to the 2x, and then on this side x e to the 2x, and then our derivative e to the 2x plus 2x e to the 2x. Okay, so here again, when we cross, we get 0 minus, and then this winds up being x times x plus 1 e to the 4x. Okay, so we are left with a negative x squared plus x e to the 4x. All right, and the last one I want to do is w sub 2, which is very similar. Now you're putting in your 0 and the function in that last column. Okay, so here what I have is e to the 2x e to the 2x, and then 0, and then our function x plus 1 e to the 2x. So again, when we cross here, we're going to get x plus 1 e to the 4x, and then minus 0, which is just giving me that x plus 1 e to the 4x. All right, so now that we have w sub 1, and w sub 2, right, we could find out what u prime is. So here, u prime sub 1, right, is going to be w sub 1 over w. Okay, which in our case is going to be, what's w sub 1? Is just e to the 4x. Oh no, that's, my bad. So w sub 1 was negative x squared plus x e to the 4x over e to the 4x. Right, so that's nice. So we get u sub 1 prime is just going to be a negative x squared minus x. All right, so let's keep that in mind. We're going to need that in a bit. And then the last one, u sub 2 prime is going to be w sub 2 over w, which we get x plus 1 e to the 4x over e to the 4x. So I just wind up with x plus 1. Now, so these are derivatives, but if we go back up, I just want to have u sub 1 and u sub 2. So I have to take, basically I'm taking the antiderivative of u, right? So antiderivative, so u will be, u sub 1 is going to be negative 1/3 x cubed minus 1/2 x squared. Don't worry about the c's in here, okay? And then do the same thing to get u sub 2, which is going to be 1/2 x squared plus x, okay? Now let's put this all together, right? So we already knew y of c is what the first thing we found, which was we had c1, I'm trying to remember, yeah, c1 e to the 2x plus c2 x e to the 2x, right? X e to the 2x. Now our particular solution, we're going to use this, u1 y1 plus u sub 2 y sub 2. So I get u1, which is a negative 1/3 x cubed minus the 1/2 x squared times y sub 1, which is e to the 2x, and then I get plus u sub 2, which is x 1/2 x squared plus x e, oh, and then I need another x. Right, x e to the 2x. Okay, and we could clean this up a bit. I mean, if you distribute, you're gonna get like 1/3 x cubed e to the 2x minus 1/2 x squared e to the 2x plus 1/2 x squared x cubed, sorry, e to the 2x plus x squared e to the 2x. All right, and then cleaning that up, I get 1/6 x cubed e to the 2x plus 1/2 x squared e to the 2x. So that's your y sub p, right? And then to put it all together, y is just going to be y sub c plus y sub p, which equals c1 e to the 2x plus c2 x e to the 2x plus 1/6 x cubed e to the 2x plus 1/2 x squared e to the 2x. So again, this is just another method of solving. I'm going to do another example video for the next section as well. So, you know, for 4/6, I mean, this is just another option, and as long as you do this correctly, you should have no problem, okay?